What's different about this is we're taking what were independent devices. You used to have servers and you had networking and you had security technologies, and we're packaging them all together into a single unified device. Yeah, if you haven't heard of Nvidia, they're a large AI company.
No, they were gaming. Sorry, go on.
No. But what's interesting is every GTC, they make large announcements and they announce new things that they're doing with their partners. And so 2 GTCs ago, we announced an initial partnership with Nvidia.
Yeah, I'm glad you mentioned that because, I was speaking to a colleague and it's like, okay, so you would put AI in a robotic device, but there's all this delay going back to the data center. That thing's going to be walking and suddenly it's going to just come to a halt. And that's just one of the use cases of that.
Yeah, none of that processing is going to be done in the data center.
Hey everyone, it's David Bumble back with the amazing Kevin from Cisco. Kevin, great to have you back on the show.
Thanks for having me. I love being here.
So I've got to tell everyone, we did a TikTok together. And impressive for both of us, 2 million views when you were explaining some basic technologies. So we might do some of those, but here we're doing a long form video, an interview, and specifically about the Cisco Unified Edge product that Cisco have announced. So I got to ask you the question, what is this? And why do I care?
And it's interesting, Unified Edge doesn't really tell you much about what it is, but what we've done is we've taken all of the different technology stacks that customers have to deploy, put them together into a unified device or kind of a composable device that can then go anywhere in our customers' network. So if you think about, we talked a lot about big AI networks and massive clusters. This is not that. That's still going to be deployed in a large data center. But when you want to take the technology outside of the data center and put it into a retail location or into a branch office or into a manufacturing floor, you might want to put it together in a smaller form factor and integrate a lot of these devices. So that's exactly what it is.
Is it like a server or is it like a switch? What is it actually?
So yes, the answer is yes.
Okay.
It's a little bit of all those. So if you think about the traditional way, let's say a large coffee company that has many stores around the world. If you look at how they do their IT infrastructure in the back of the behind the little kitchen and everything in the back there, they do have IT equipment and they have servers and they have switches and they have storage. But in general today, it's a big rack of stuff with cables and wires, and the barista who's making the coffee is not really the one that you want back there moving wires around and doing things. So we've kind of taken all those technologies and brought them together into one single unified device, but then we've created it so that it's composable. So if you need more switching, you can put switching blades in it. If you need more storage, you can put storage blades in it. If you want to put GPUs in and actually run AI inference in those nodes, you can do that without having to deploy yet a different device with a different management system and a different infrastructure.
So it's like a number of it goes into a rack in the back, and it just saves you having like a server, switch, and everything racked individually with all these cables. Is that correct?
Think of it as having sort of slots in the front, and you can slide these sleds in. And so there's 5 of these sleds that you can slide in, and if you want 5 of them to be servers and just have a bunch of servers in one unified system, you can. If you want to have less compute nodes but add GPUs or add storage, you can do that as well. So it's composable to be whatever the consumer needs in that application.
So the reason for this, it's surely not just cabling, right? Are there other reasons why this was done?
Yeah. So cabling is the simple and easy one. If you go and look at one of these mess of a racks that we have in a lot of these places, there's just spaghetti of cables all over. It probably looks like one of the labs I built many years ago. But beyond that, it's about operations too. So if you think about being able to remotely manage these devices, if you're an IT administrator or a server administrator, you have your systems in the data center that you know and love. But if you want to deploy this in a remote location, you can use these SaaS-based management tools and actually manage from the cloud. So instead of having the barista have to go back there and configure and do things, once they plug it in, they literally put the device in, plug it in with power, put a network cable into it, and then there's a little QR code, and they scan it with a phone, and off goes to the administrator, and the administrator can then manage that device from there.
So you're talking about AI in a coffee shop as an example, right? Yeah. Why would you do that?
So think about, and you can go back and watch some of our videos before where we talked about why we build large AI clusters.
Yep.
Once we train these massive models, the models are smart.
Yep.
You might do what we called fine tuning, and you might fine tune with the specific data for that application or for that consumer. But then you want to use the model. And so inference is about using the model. The other interesting thing when you think about remote sites is things like video cameras, like the fact that you want to do local processing of video footage and be able to make decisions right there. And so a lot of these require more horsepower on site instead of sending all that data back to cloud. And that's one of the big use cases that we see.
So as an example, you could run a local AI there that looks at the cameras and makes decisions based on what it's seeing kind of thing?
Yeah, think about retail. You can look at inventory if you wanted to. You could see I love the coffee example because everybody understands what it is and it makes sense. But you could see, the number of bags of coffee or cups that are sitting on shelves, and you could understand when you have to reload those or restock those. You can use it for understanding traffic flow of people. Where do they spend the most time, or what's most interesting to them. You can look at it for bottlenecks in your operational process, and you can make your whole workflow more efficient in how you want to manage your business. And so there's a ton of use cases. Those are more retail. But think about when we start to take AI outside the data center and into the physical world, and we have, robotic manufacturing facilities, and their cameras and on-site processing and compute power are going to be critical.
Yeah, I'm glad you mentioned that, because I was speaking to a colleague and it's like, okay, so you would put AI in a robotic device, but there's all this delay going back to the data center. That thing's going to be walking and suddenly it's going to just come to a halt. And that's just one of the use cases of that.
None of that processing is going to be done in the data center. NVIDIA actually describes this really well when they talk about the 3 different computers that you're going to need for AI. And so you're going to need these massive training models and sort of the intelligence. But then you're going to need to have another computer that models the environment. And so I've seen some really cool demos of this where they have a model of the physical world. And so once you build up your robot brain, you actually have a bunch of these emulated in that world, and that world then allows them to practice bumping into tables, and if they fall on the ground, how do they get up? If there's other robots walking around, how do they avoid them? And so you train the model over and over again with that real-time data, but then you have the computer that's going to be running locally. So once that model's trained, that model runs on a smaller form factor of these GPUs, or even a lighter weight GPU, or maybe even a CPU. And then it makes the localized intelligent decisions, because you don't want tons of latency. If you're about to go run into a wall, or worse, run into a human or potentially cause damage, you don't want that decision to have to go all the way back to the cloud and come back.
So the vision is there'll be an AI model in the robot, and then an AI model perhaps in a store, and then an AI model in the cloud somewhere.
Yeah, the interesting thing about this is you have to think about every aspect of how these things work. So when the model is sitting in a data center, we understand security. We understand all the aspects around building safe and secure AI inside of a data center. When we move to this world of physical AI and we move outside the walls of the data center, we have to rethink security. We have to rethink, how everything actually runs. How do we identify, what was hundreds or thousands of devices, running locally, to millions and billions of these devices running in the free world? And so once that happens, how we do security, how we do policy for these different devices, all of that is going to have to change, and that's some of the stuff that we're working on.
Yeah, so tell us about traffic, because I'm assuming there's going to be more traffic now. It's going to affect the network from a bandwidth point of view, but a security point of view as well.
Yeah, so okay, I mentioned everything's going to have to change. So think about traffic. Think about how we all started using ChatGPT 3 years ago. It's almost 3 years exactly from when this stuff launched, which is still in infancy in terms of its technology growth. But we would send a query, and it would come back with something. It'd do some processing, and that exchange is basically tokens. When we talk about tokens, it's tokens going in, tokens coming out. As we've evolved into this world of agents and what we call agentic workflows, now you might actually have multiple agents operating on your behalf.
Yep.
And so they have to go out and they have to grab data, and they're passing tokens between them as they make decisions. And so they may come back to you with a single answer, but it's going to be multiple agents working together, accessing multiple sets of data. So there's just the data flow problem, more and more data passing between more and more of these devices, changing the way we use the network. But think about it from a security perspective. So when you log into your device, I know it's you, and you have certain sets of permissions, and I allow it to happen. What happens when you kick off 100 agents to go perform functions for you? What rights do they have? Do I have to protect them from access to things, or from things accessing them? How do I monitor them to make sure they haven't gone rogue and they're not misbehaving? And so it's kind of scary, but it's futuristic when you think about it. We're going to have to use AI to sort of protect ourselves from the AI, because the human brain can't comprehend the amount of volume that we're going to see in this space.
Yeah, so huge spike in volume, huge issue with regards to security. But I'm assuming Cisco working on these problems and have got solutions that are either here or coming.
Yeah, absolutely. I mean, we're always working on these solutions. We've kind of transformed how we see identity and security working. Today, the way these work is we have agents in tools like something we call AI Canvas, which is a tool that allows us to operate and manage networks. It'll allow you to make changes to, say, the operating config of a router. But even when you go in the logs, it says, change made on the behalf of Kevin Wollenweber by the AI Canvas agent. So the identity is still locked to you, But over time, we think that agents themselves are going to have their own identity, and you might have different permissions for your, highly confidential agents that might have access to your own personal information, and then you might have the equivalent of public agents that can access the internet and kind of the known data sets in the world. And so the volume and the number of agents, the volume and the number of rules means the traditional way of doing things where we have static rules that live forever can't actually exist anymore. And so we have to use more dynamic rule setting and use AI to actually identify and create those rules.
So, Kevin, this device, I don't see anything like exceptionally new in this. Perhaps the GPUs are new, maybe, but it seems like something that's very similar to what we had in the past.
Yeah, and actually we've had GPUs in computer. We have them in the UCS portfolio already. But what's different about this is we're taking what were independent devices. You used to have servers, and you had networking, and you had security technologies, and we're packaging them all together into a single unified device. And that device is composable. So if you need more compute, you add more CPU and memory. If you need more storage, you add more storage. If you need more GPUs, you can add GPUs in these sleds and then allocate them to the compute node that's there. And then you can put a networking blade in that looks just like a Catalyst. It actually is the exact same device that we're selling in a Catalyst form factor. So you can operate it and manage it in the exact same way you would manage those networking devices if they were independent. But it's all common and in one single ecosystem that's easier for customers to deploy.
So I believe you were at a conference last week with a lot of people will say very well-known company, Cisco very well-known, but Nvidia as well, partner of Cisco. Any interesting updates from that conference that you can share?
Yeah, if you haven't heard of Nvidia, they're a large AI company.
I thought they were gaming. Sorry, go on.
No, but they what's interesting is every GTC, they make large announcements and we announced a partnership. GTC is their global conference, their global technology conference. They announced new things that they're doing with their partners. And so 2 GTCs ago, we announced an initial partnership with NVIDIA. We've been evolving that partnership over time. What we announced a couple weeks ago was the ability to take their spectrum, their forwarding technologies, and integrate them into the Cisco ecosystem. So we can take our operating system, the Nexus operating system or NXOS, we could run it on top of their switches. So if you want to build out AI infrastructure and put it next to your existing data center fabrics you've built, common operations, common management, and so it looks like a Nexus switch, but it has some of the embedded NVIDIA functionality. So as you're building out large clusters, you get all the goodness of running NVIDIA, but at the same time, operationally, it's consistent as you would with a Nexus fabric.
So just for people who don't know that, just explain a little bit. Before this was announced or is being implemented, did NVIDIA have their own switches? Because people think about GPUs mainly, but did they have their own switches running their own operating systems? Was it Ethernet? How did it work? And how's it changing?
Yeah, well, so kind of look through the whole continuum. When we build data center fabrics, we build large Ethernet fabrics. We use standard technologies like EVPN, VXLAN to build all those fabrics. And so you can build simple, consistent fabrics in your data center. As AIs come in, we've introduced new networks. And so we have this concept that we talked about previously of a front-end network and a back-end network. The back-end network is just to connect the GPUs together efficiently. We have these concepts of scale-up networks and scale-out networks. So you can build up GPUs in a rack that are all connected together by scaling up, and then you can connect those racks together across by scaling out. We also even introduced something new that we call scale across, which is if you have to go from one data center to another, and build large GPU clusters across those. And so with all these new networks, what customers don't want to do is manage them separately, like a different management ecosystem for scale up versus scale out and a different ecosystem for front end versus back end. And so a lot of these announcements are about bringing those together and making it simpler and easier for customers to deploy.
In other words, it's an NVIDIA hardware switch that's now running Nexus OS.
Yeah, so it's an NVIDIA hardware switch. They build Ethernet silicon as well. It's an NVIDIA hardware switch that's running NXOS. And in conjunction with that, we announced the ability for us to also take our Silicon One-based switches, run a license that enables NVIDIA functionality across those. And so you can get similar properties as you would if you were deploying the NVIDIA architecture across the Cisco silicon as well. And so you can think about giving our customers multiple deployment options and actually building a new reference architecture, something we call the CRA or the Cloud Reference Architecture, that allows you to deploy with Cisco devices and NVIDIA GPUs, with NVIDIA GPUs and NVIDIA switching, all of it with common kind of operations and management with that NXOS operating system.
So just for people who don't know how data centers work, I always like to ask you this because you guys, you're involved very heavily in this, but not everyone works in a data center. Is it just getting bigger and bigger and bigger?
So I've been in this industry for almost 30 years, and the size and complexity of these data centers today is orders of magnitude greater than what we've seen in the past. If you pay attention to what's going on in the news, we talk about GPUs, we talk about switching, we also talk about power and nuclear power systems being brought online to power these data centers of the future. And so I think power and efficiency are going to be critical as we build out data centers. Most of the next few years, we're talking about building gigawatts and tens of gigawatts of capacity. And tens of anything sounds like a really small number, but gigawatts is a really big number. And so every one of these is not just a building, but multiple buildings of data center capacity all networked to get together. And when you build out data centers of this size, the networking technologies inside and the way we connect them become even more critical because it's thousands and thousands of switches at the end of the day.
And speeds?
Okay, so speeds is fun because we used to increase the speeds of these devices. Go back to the old Ethernet days, which unfortunately we were all around for as well. 10 meg to 100 meg to 1 gig, and you went in these 10x increments. Now the increments are more of doubling, but we're going from 400 gig to 800 gig. We're now delivering 1.6 terabit interfaces over the next year or so, and moving to 3.2 terabit and beyond. And so the pace of change of these technologies every 12 to 18 months, where we used to go 10x every 4 or 5 years, is accelerating at a pace where not very many people can actually keep up.
And I heard about this new router that Cisco created for scale across, where you link multiple data centers together, right? I mean, the speeds in that is crazy, right? Is it 3 exabytes or something?
Yeah. Well, what's really crazy is just the chip itself. So this is a 51 terabit, 51.2 terabit to be exact, ASIC, with all of the capabilities of a high-end router. And if you go back in history, I know we walked through a history museum one time and looked at some of these technologies. We had a product that was called the CRS. It was a large-scaled routing device that took up multiple racks.
Yeah.
That was 51.2 terabits also, and it was 9 racks of equipment with 8 racks of forwarding, with 1 rack of fabric to connect it all together, tons of fiber optic cables behind it. You can now do that in a single ASIC. And so in a single couple RU device, I can build the same amount of forwarding capability from a routing perspective as I had a decade ago at an order or multiple orders of magnitude less power, 3 RUs versus 9 racks of space. And so it's just amazing the consolidation and the technology evolution that we're seeing.
Yeah, so I mean, the problem with power and water is hitting big time at the moment. So the whole idea is make the devices small and use less power. Is that where it's trending?
It is, because the number of these devices that are getting consumed is going up rapidly as well. And so, it's like any curve. At some point, we have to figure out how to change the slope of the curve. We can either figure out how to do things with 10x less power, which is really difficult to do at this point, or we can just figure out how do we make these things as simple as possible, remove functionality from them, and really optimize them for AI, which is the predominant workload that we expect to see for the next few years.
So give us an idea of where things are going. We've got AI on the edge in this device. I know you said in the past there was like multiple devices, but we've got this device on the edge that's doing local AI. And then we've got AI in the data center. Where are we going? Is it just more AI all over the place?
Yeah, so think about massive, these gigawatt clusters we're talking about, massive clusters will be built just for training the models. So you send a ton of data, you train the models. Here's where you have hundreds of thousands, if not, approaching millions of GPUs connected together, just trying to solve this one problem of training a model. Then once we have that model, they will use distillation methods or others to kind of shrink the model. They want the model to actually be smaller so that you can run it in a smaller number of GPU resources. And then that model will get put everywhere. So when we talk about inference, or when we talk about physical AI and the robots that have these GPUs in their systems and they're running the models themselves, that's where we're going to see massive adoption of GPUs or compute for inference. Today, the last 3 years, majority of the spend is towards those big training clusters. Over the next few years, that's where we're going to start to see more and more people using the models, which means more and more usage of inference and sort of that distributed inference across the network.
So just for people who don't know, inference is where it's learned something and now it's actually applying that, right?
Yeah. So I very simply, and it's much more complex than this, all the AI people will probably say, that's a very simplistic view, but just think about it as training or building the model versus using the model. And inference is really about using the model for a specific function.
So Kevin, we've got these agents running around, for lack of a better term, doing all kinds of things. I think people have concerns, firstly, with security is a big one. If you're giving this agent the ability to make decisions by itself, what happens if that agent's poisoned or hacked or something? Cybersecurity is a big issue. And then also the way the network works. So perhaps you can touch on both of those.
I think the first thing to think about is just where we've come in the last 3 years and what these agentic workflows actually mean, right? If you look at what we were all doing 3 years ago, there was this really cool thing, ChatGPT. We could ask it questions and it could respond back. But if you go back to GPT-3, it was useful and it was intelligent, but the answers weren't always great and the responses weren't always exactly what you were looking for. If we look at where we've come in the last few years, the models themselves are extremely intelligent. They're trained on tons and tons of data. Now we're starting to think about real world applications for those. And so these things that we call agents, think of them as small workflows that can run and process things for a longer period of time. So instead of just simple questions and responses, these are things that can reason with themselves. So they can go through and come up with an answer and then kind of reiterate that answer in their head and say, I think I can provide a better answer. Let me grab some more data and think about this a little bit longer and come back. And that's led us to things like deep research, where you can ask it to go, research all of the, I use it for researching the reports that come out from a lot of my competitors just to understand what they're doing. And you say, research the last 10 of these reports and come back to me with this, and this. And it will go off for minutes, for tens of minutes, for hours, and then come back with data. And so if you think about that does a couple of things. One is it's running on the network longer and it's accessing more pieces of data. And that data can be inside of your network or it can be in the internet itself. And so one of the things that we're really focused on then is not only what do we have to do inside of the network to be able to handle this larger traffic load and all the communication paths, but what do we have to do to secure it? And how do we know that these are your agents and they're actually allowed to access this set of data? Think about the medical industry. We have people that are using agents to answer questions on your medical history. And so you might have some agents that have access to your personal information and some that don't. And how do we make sure that we're the right agents are accessing the right data and not going beyond their credentials? So it's tons of work happening in what we call identity, which is understanding the agents and who they are. Tons of work that are happening in policy, which is applying the policy and telling the network, allow this agent to do this or don't allow this agent to do this. And then even more work happening on how we protect the models themselves. So how do we sort of wrap the model with what we call guardrails to make sure that it's doing what we wanted it to do, it's not answering questions it's not supposed to answer, and that it's safe and secure because it has so much data inside of it that people can get to it and potentially use it for malicious things.
Yeah, I mean, we've spoken about this before, right? Networking lost its shine for a bit, but it seems like networking is so cool and so important now with all these changes with AI, right?
Yeah, I mean, I look at the idea or the thought of building multi-gigawatts of data center capacity. A GPU is a really important tool, but a GPU is worthless if it's not interconnected, and that is networking. And so the fact that we're evolving Ethernet, at a conference called OCP a few weeks ago, we announced this thing that's around Ethernet scale-up networking and taking Ethernet, the technology that we all know and love and we've used for decades, and optimizing it for connecting GPUs together. So there's going to be a ton of work that's going to happen in this area over the next few years as we look at, not just the last 3 years of ChatGPT, but really where AI is going and what we have to do to make sure networks continue to scale and allow us to connect GPUs at massive quantities.
People always worry about jobs, right? But it sounds like there's going to be a lot of jobs for network engineers.
Yeah, and there might be different jobs. So you're right. There are certain things that are becoming easier and simpler to do with AI tools. But one of the things that we say a lot, or that I see, is your ability to use these tools and leverage these tools and learning how to use these tools is going to be critical to your success moving forward. So network engineers absolutely going to be there. Network engineers are also going to have to learn new skills and learn, how do we use the tools that are being offered to make them more efficient so that they can actually do more on these networks.
But as an overall vision, AI is going to be everywhere, right? Locally on devices like robots, but lots of devices, perhaps in cars, all kinds of devices on the edge, if you like you use the example of a famous coffee shop. and in data centers, it's going to be all over the place. Is that where it's going?
Yeah, and one of the things I like to say is today we still treat AI as a thing. Yeah. It's something specific that we're doing, and we're building clusters for it. I actually have this view that over time AI is just going to become part of, if not everything, that we actually do. And so data centers are being rebuilt to optimize for AI. We're talking about moving AI into the physical world, and we're going to have robots and physical AI entities working and managing and kind of moving around among us. And so think about it in the next few years of AI just being something we all have to understand, and it's part of everything we do. It's not a localized and specific thing that we can control.
Kevin, we're out of time, unfortunately. Great to see you again. Thanks so much for sharing.
Yep, thanks.